let's take a piece of this circle. So let me mark out the center. And there's my radius. I'm just going to grab some other part of it, and that's the radius. Now let's say I want to find the area of this piece of the circle. Okay, from the initial to the terminal there, we would have our arc length, which we've called S. Now what I'm going to do is take this little piece and just kind of pull it out of the circle and make it look like something a little more familiar to you. Almost kind of looks like a triangle. So recall that the area of a triangle is 1/2 base times height. So the way that I remember how to find the area of a sector of a circle is very similar. The area of a sector of a circle is 1/2, and the base was the arc length, and the height is just the radius. And remember that arc length can also be found by doing r times theta. So if I replace S with that, we could also write this as 1/2 r theta times r, or 1/2 r squared theta. So we actually have two formulas that we could use. So let's do a couple examples. Let's find the area of the sector of the circle. I'm going to give you the central angle and the radius. So let's say that the angle is 2. Now remember, if there's nothing written after that, that's assumed to be radians. And let's say the radius is 6 feet. Okay, so because I'm given r and theta, the second formula makes more sense to me to use. So a would be equal to 1/2 6 feet squared times 2. 2's would just cancel, 1/2 times 2. So then 6 squared is 36. Square the feet as well, so you have square feet. That theta is in degrees this time. Let's say it's 120 degrees. And let's say that the radius is 3 meters. So again, since r and theta are given, I should probably use the second formula. So 1/2 times 3 meters squared times 120 degrees. Now notice what would happen when I go to multiply all this out. I would have square meters times degrees, which is not the units that we're looking for with area. So what I need to do is change this degree into something dimensionless. And that means radians. So what I'm going to do is change 120 degrees over into radians by using our conversion. That 1 degree is pi over 180 radians. Okay, so again, I just changed this 1 degree into pi over 180. So now I'm going to end up with square meters. So let me simplify anything that I can. Let's see. 1/2 of 120 is 60. Let's just go from here. Well, maybe a little more. So then 60 into 180 would go 3. Now when I go to square 3 meters, that's going to become 9 square meters times pi over 3. So then 3 goes into 9 3 times. So I end up with 3 pi square meters.